Hi there, welcome to John Stewart's Calculus Early Transcendentals 9th edition. We're solving question 30 from section 3.1 today, and instructions for this problem is just to simply differentiate the function, so let's jump into it. The first step is to basically identify what you have and see if you can put it into a standard format so you can apply the formulas given. At this point, you don't really have a lot of formulas. Our basic polynomial derivative rule is basically x to the n. The derivative of it is you take the n, you put it down in front, and you subtract 1 from the exponent. As we can see, we don't have quite the same format though, because we have some brackets raised to an exponent, and we can kind of view this as an inside and outside function, use something called the chain rule. However, that's learned in a later section, so right now you're not supposed to know it. So we have to get rid of the bracket another way. And the way to get rid of the brackets is through multiplication. So you can look at that 1 plus q to the power of negative 1 all squared as being the same as 1 plus q to the negative 1 in brackets times 1 plus q to the negative 1. And then here you can just apply the FOIL formula, which is sort of grade 9, grade 8 math. And you basically take the first two pairs, multiply together, the inside two pairs, outside two pairs, and last two pairs. And of course, FOIL just stands for first, outside, inside, last. And yeah, it's pretty simple. I mean, your first term is going to be 1 times 1, which is just 1. You're going to get q to the power of negative 1 times 1, which is just q to negative 1. You're going to get another q to negative 1. And finally, the last two terms are going to be q to negative 1 times q to negative 1. And then we just try to simplify and group like terms. Now remember, when you multiply two polynomials together, you always add the exponents. So because we have a q to negative 1 multiplied by q to negative 1, we have to add negative 1 and negative 1, which is negative 2. So after we simplify, we get 1 plus, and we group the two q to negative 1s together, so we have 2 q to negative 1s. And then because we're adding those exponents, we get negative 1 plus negative 1 is q to the power of negative 2. And now we're finally ready to take our derivative because we've got a nice standard format. Alright, and so once again our basic polynomial derivative rule is up top, and we also have to remember the derivative of a constant is always 0. So you can look at the derivative of that whole expression up top as being the derivative of the three parts individually, if that makes it easier for you. The first expression is just derivative of a constant, so it goes to 0. The second expression, we're taking the exponent and we're dragging it down in front, which is the negative 1, and then we're subtracting 1 from the exponent. And the rest pretty much stays the same. For the second term, we're taking that negative 2, we're dragging it down in front, and we're subtracting 1 from the exponent. So the 0 just drops off because you don't have to keep writing 0. The second term, if you take the negative 1 and you multiply it by the 2, you get negative 2. And if you go the negative 1 minus negative 1, you get negative 2. So that becomes q to the power of negative 2. For the third term, if you multiply that negative 2 by the q, you just get negative 2q. And if you take the exponent where you have the negative 2 minus negative 1, you just get negative 3. And so yeah, that's pretty much the solution right there. Negative 2q to the power of negative 2 minus negative 2q to the power of negative 3. An optional step, if your teacher is really strict about it, is you could get rid of those negative exponents by moving the q onto the bottom, as shown below. But it's kind of optional. I think both answers look pretty good to me. And yeah, if you're looking for a solution to another problem and you want a step-by-step guide, just try to give me a picture of the question if you email it to me, or let me know what chapter and textbook and problem. Thank you very much, and look forward to seeing you in the future. Bye.